Good afternoon, everyone. My name is Stefan Lodewijks. I am the co-founder and CEO of Aug.e, and it's a pleasure to be able to explain you a bit more about what Aug.e can bring to you on smart energy and more. So in core, Aug.e builds a digital fabric around a building, and by means of creating that digital fabric around the building, we can make the building more efficient, we can actually make it more sustainable and make it true customer-centric. And now the question is, how do we actually do that? So the how, in a high-level perspective, is we create a digital twin. So that means we mimic the reality of the building. We add a lot of metadata from the design, but we also add metadata from really the operations, augmented with other data. And then we bring various use cases to life on that digital fabric. They can range from energy towards facility management, meeting room management, security, all types of use cases that are possible on that digital twin layer. So Aug.e is actually something that originated from the energy, and a bit of background around that was the two founding companies besides Ileco, being Basics and Proximus. They already a couple of years got confronted with the fact that these buildings need to become more smart, more digital. And that was the big theme about smart buildings with a lot of use cases. But throughout the years, it became very apparent that the main use case to enter the building would be the energy use case. So from that perspective, that's when the three companies got together, Basics, Proximus and Ileco, and the investment happened. And now actually there's the strength of the three companies. So the entry point is energy, the element about the construction comes from Basics, and the connectivity, security and the cloud element and expertise comes from Proximus. And there will be three representatives, being myself, Bart, and the CTO coming from Proximus. So when we start from the energy use case, actually we have to explain a bit more about the whole energy system as it's now. So the energy system as it's now is still a very centralistic energy system, where there's a lot of energy being produced on a local manner, whether it's nuclear power plants, gas power plants, or big windmills in the North Sea, very centralistic and kind of consumed also on a very much centralistic, easy, predictable manner. Going forward, and that's happening now, there's a much greener energy system, and that actually leads us to a prosumer system, meaning that the customer will be part of that energy system, will not be only a passive consumer, will need to consume when the moment is right, when there is a lot of green energy, will therefore have to change his behavior. If he does not do that, he will first of all not be sustainable, but secondly, more importantly towards the customer, he will be paying a lot more money, because when there is not a lot of green energy, there will be other energy which will be a lot cheaper. So you arrive at a distributed prosumer customer-centric energy system, and that's actually the core where Aug.e starts from. So the starting point again is energy, and the high-level scheme about how we handle that energy system is again from that data core, that digital twin, that incorporates building models, incorporates models of the assets within the building, whether those are thermal elements like the heating part, like the cooling part. Mobility, we have a shift from fossil fuel driven mobility towards electric mobility. That's also added into the model. Other elements too, and then it's enriched with other data needed to perform the forecasting and the control for the optimization of the building. So extra metadata can be the weather forecast, but it can also be kind of extra buildings surrounding that, how they behave, how they impact on the behavior of that single building. And obviously also the energy markets, which are continuously in evolution. So the energy markets, well known or maybe not well known, is it's kind of slashed into a couple of elements. That's the high voltage operator, in this case that's Elia, the mid voltage ones, which you see the cabins in the field, and those can be like a Sibelga or a Fluvius or Reza. And then you have kind of the energy markets that comes for the price forming of the actual energy prices, being the apex spot market. So all those are added into that digital twin, that digital layer. Data is captured, energy streams are forecasted, and behavioral patterns are changed. Also assets are changed, are controlled, are optimized to make it more sustainable, make it more green, and also kind of align with the new energy market. So that's what the high-level scheme of smart energy management is about. So what type of results can we achieve then? So we can achieve results on the first one. The most efficient element of the new energy system is still not using energy. So every kilowatt hour, every energy unit that you don't consume is one that is extremely sustainable and that doesn't cost anything. So by means of that digital twinning concept, we can forecast the behavior of the building. We can optimize, still staying within the key elements of the facility manager, being I want comfort. I have a certain need of comfort within my building. And so within those comfort regions, can you minimize my primary energy usage and primary energy costs? So we benchmark that, we optimize, and we continuously look at the optimization, and therefore we can save money and save energy consumed. So we do that on one building, we do that with EV, we do that with multiple assets, we have multiple channel partners already, multiple buildings already active in the field that way. We do that obviously with more buildings, and more buildings, then you start getting closer towards where the energy part of Aug.e originated, being ILECO, that's standard for Intelligent Local Energy Communities, so that you can actually cluster multiple buildings. You then arrive at the end goal and the architecture of the future energy system, where Europe also typically says they estimate that about by 2050, 50% of all energy transactions in the European community will be based on local energy communities, meaning I want to maximize my self-consumption within a certain physical constraint, whether that's an apartment block, multiple office buildings, an SME zone. I want to kind of maximize my demand and supply matching within that on a real-time manner. That becomes an energy community. So that's a core element. At the moment, we already have multiple customers' projects up and running. Within Europe, we're kind of definitely a forefront runner on that fact. And this is an example where also here, this city, this township has the ambition by 2030 to be energy neutral. So energy neutrality, they could do that by means of buying green energy credits. For instance, they buy green energy in Norway and they say, I'm green. That could be an option. Or this city wanted to have really localized sustainability, local greenness. So that derives then, they want actually an energy community, but they do want their brand, they want their identity within that energy community. So what we do for them is actually a full end-to-end solution, from the data capturing, engagement of all the customers, the coupling towards the energy markets, the trading, the local platform which first facilitates 15-minute local optimized trades, then looks at what can I do outside of the boundaries and trades that on the national level, and brings that then towards live towards end consumers in different UI formats, which can also be exposed on an app. So the end user gets informed about how sustainable he and his community is, what he can still do to improve, what assets he can buy, what other energy strategy, what behavioral changes he can do. He can benchmark himself. So all the tools are there to actually deliver a full sustainable energy community. So once we are kind of past the energy, and obviously there's still a lot of different use cases on the energy, but the core of Aug.e was I want that digital layer starting from the energy part, but I want to extend that. I want to kind of potentially also have other metadata incorporated. I want potentially also some extra input-output when I go into a building. And the reason why I want that is because actually I want to be able to unlock multiple use cases. So if I, for instance, want a security use case, if I want kind of an admission use case, I would have to also incorporate the link towards either my mobile phone or, for instance, a reader to see where people are and to kind of link that with the security. Now, typically that would not necessarily be done with the pure energy part, but that data can be used to improve also the energy case. But the same security and authentication case physically within a building can definitely be enriched by means of the deep integration that the energy use case already had to go through. So that means it's a win-win from a platform perspective, and it's a win-win also for the building owner, the property owner, facility manager, because they have really their digital fabric at their hands, and it's for them to decide who and what gets exposed on that digital fabric. So we have the approach, the architecture, which goes from energy into the full chain, and then actually we have multiple users that can use that. So you can have the core users, you can have the service users. The core users are typically ones that say, well, I have a direct need attached to the building. So that can be a facility manager, that can be someone that has to do service and operations, can be actually also someone purely of HR. So multiple people have multiple reasons. If I, for instance, take the facility management case, typically, at the moment, these office buildings are managed by facility companies, and they will look at the BMS, the building management system, purely from a very engineering look and feel, and typically a localized engineering view. They will only get access to that data, and they don't typically get any usage data from the building. And meaning, if there are events, if there are problems, someone at the reception gets informed by a problem, they have to call the facility team, facility service team. They have to look into this cryptic engineering view, missing some data, and it takes a long while, and maybe they don't take the right action. In that new world, that same data, but enriched with other data, for instance, where users are, how much times anomalies have been detected, and presented towards someone that is maybe not technical, but presented on a very easy, agile, digestible manner, can already have a first line facility management service without immediately falling back on the cryptic engineering tools. And so that's kind of a use case which dealt with in this digital fabric layer can be giving a full different experience, and a much better also experience than using the old tools. Then obviously, and I've been kind of mentioning that a bit, these service users, so that can be typically a visitor, but that can also be an employee, that can be also a technician that comes there for a specific problem. So that might be someone from the service desk, from the previous core users, that says something's wrong with my HVAC. Well, he has to go there, doesn't have enough data, actually has to explore it again himself. If he would be exposed to that same Aug.e shell with the other enriched data, he could also leverage on the historic data from the as-built. So the as-built would have metadata throughout the life cycle of that building, which would help his intervention as a technician to resolve the problem on the HVAC installation, as an example. Same obviously with normally an employee. An employee could maybe use a very shallow app to do a booking of a meeting room, but connected towards all these different input-output of the BMS. The meeting room booking could be a lot more rich, could incorporate a lot more data, could incorporate a lot faster, more efficient, and therefore more efficient uses of the building. More efficient uses of the building would also mean more sustainability. So every user has their needs, and this layer can actually present multiple views of that need. So that viewing then comes back to, you kind of have more the engineering view of the facts, and you have more the end service user, which typically would be exposed on an app, and all they will be connected by means of, again, that digital fabric. So just some flavors of what the engineering look and feel could be. It's an object structure which represents the reality and all the assets and the building and the relationship it has between each other on a structured manner, where the algorithms, the user interfaces can make use on a very generic manner. One could then see that purely on a tree structure, flat tree structure, or you could see that in a 3D view with overlay of the metadata for the use case that you're interested in. Another example from the engineering view could be, again, you have the overlay of the 3D view with, for instance, anomaly detection, pattern detection, showing it the way that the user to consume that service would want to feel most comfortable with consuming that service with. The app, again, that's typical, the app in the App Store, and that then boils down to different use cases within that app, whether it's a meeting room, whether it's chair reservation, whether it's kind of being able to interact with the comfort of the building, facility management, kind of also authentication within the building, route finding, coupling with your electric vehicle. There's multiple things that can be enabled in that app. And as one last example, we got ahead of us this very interesting renovated building, the Manhattan building in the center of Brussels. So it was an old building, was extremely well physically renovated towards a cutting edge, nice looking building. But actually the digital part was only a shallow. So there was a building management system on a typical rule-based manner, but all the new experiences which resembled the nice look and feel physically of the building were not there. So we were tasked to actually do that digital fabric around the building, and we're now adding on whenever the property manager, the facility manager feel adequate, more and more services can be on there, ranging from integrating the EVs, obviously energy efficiency, the trading, meeting room occupancy, and so on. So multiple services throughout the time will be enabled by means of that digital fabric. So this was, in a nutshell, the reason why Aug.e started, what we do, and that digital fabric, we bring multiple use cases on the digital building, and what it can mean to you. It can mean to you that you save money, your experience in your building is future-proof, and you actually also possess the digital lock of your building. So you're in possession a lot more of what you want to enable or not in the building versus all types of vertical service providers coming to you with certain requests. So voila, I'm now open to questions and curious to hear them. So, can I create a digital twin of my building with Aug.e? So, can I create a digital twin with Aug.e for my building? The answer is yes. So, if you have a new building with a full BIM, building information management model, then it's reasonably easy. We incorporate that in the typical standards, whether it's Revit, IFC, we incorporate that. We enrich that with potential extra data. We then would couple that towards the actual sensors and the actuators within the building, and then actually enable your live digital twin. So that's one route, and that's if you have the advanced version of all the tools. You could also have, and that's the majority, an old building which doesn't have a BIM model, which doesn't have a lot of as-built information, where we'd go in a first step, a light digital engineering, build a light, more object tree of the building, which can therefore be amended with that live incorporation of the building by means of still an old BMS, others adding potentially extra sensors and giving at least maybe a 70-80% digital twin of your building. Second question. Can you use the digital twin to evaluate a future new building setup with respect to energy consumption? So evaluate a new setup before actually implementing. Oh yes, yeah, that's actually a perfect use case. So at the moment, how it starts is when kind of someone who wants to build a building, he typically goes to an engineering company with some requirements. So for instance, I have this amount of kilowatt hour per square meter per year. That's my design criteria. The engineering company will help them with the design of an HVAC or other types of systems, but typically doesn't incorporate the dynamic element of the usage pattern of your building. So if you would start with your objectives of what you want to consume in the building, you can indeed be helped by the engineering company from the high level dimensioning of the assets. You can then amend that with scenarios, and so you could say, what if my usage pattern is this way? What if kind of the energy markets evolves that way? What if I would be able to trade? What if I would add some more comfort differences? So all that will be able to give you answers in a lifetime assessment of 10-20 years of what the cost would be and what kind of implication would be if you adapt your building with certain needs and certain assets. So the answer is yes. Okay, I don't see any further questions, so I hope you at least got a first glance of what Aug.e can mean to you. And as you can see here, that's the website, that's my name, so I'm always open to further questions, and hopefully we maybe meet each other for an opportunity later on. So thank you.
Proximus. Think possible.